Hi, I'm Cara Fan. My project is Dragonflies Beat Infection, Fabrication of Antibacterial Nanostructures for Orthopedic Implants. There are around 1 million cases of implant-related infections that occur every year in the United States. My solution is from Mother Nature. This dragonfly is called Neurobasis chinensis. When you zoom in closer, 50,000 times, you'll see millions of tiny nanopillars that can kill bacteria. The goal of my project is to biomimic these nanopillars and apply it to orthopedic implants to prevent infection. When bacteria land on these nanopillars, the nanopillars break the cell wall of the bacteria and prevents growth and immobilizes it. This is called contact killing. Just imagine a bed of long nails. Now, this uses physical methods instead of chemical methods to kill bacteria. And there are several technologies that have been used to create nanostructures, such as the use of expensive lithography machines, but these cannot create the spike of the nanopillars, which is really critical for killing bacteria. Using my method, I was able to reproduce these spikes. And my fabrication method, the first step was to create the negative molds of the dragonfly wings using PDMS. While making my PDMS solution, I had to experiment with many different ratios of the curing agent to elastomer based to find the perfect solution. The next step was to create the actual nanopillars. I used PMMA, a popular material that is commonly used for making medical implants. I draw casted my PMMA solution onto the PDMS negative molds, as shown over here. After leaving it to dry, you peel it off and leaves the imprinted nanostructures on the surface. To actually make sure that these nanopillars were imprinted, I had to characterize it under the scanning electron microscope. Here's a picture of the nanopillars that I made. These nanopillars are around 20 to 30 nanometers in length and around 200 to 300 nanometers in height. Now that I replicated the dragonfly wing replicas, I want to test if they could kill bacteria. I performed 2 different bacteria tests. The first test compared the E. coli colony growth on Petri plates. The results were that there's an 87.5% loss in E. coli viability after being exposed to the dragonfly wing nanopillars. For the second bacteria test, I used a spectrophotometer to determine if my dragonfly wing replicas could kill bacteria in a liquid solution. The results were that the bacteria growth curve for my dragonfly wing replica was lower than the control that had no nanopillars, meaning that it slowed down bacteria growth. There are several challenges that I faced along the way during my fabrication process. Now, some of the scanning electron microscope images show air bubbles or patches of nanopillars where other areas had no nanopillars. To solve this problem, I used a syringe as a vacuum chamber to vacuum out the many air bubbles. I also subjected the solutions to ultrasonic vibration to make sure it fully seeped into the mold. Isn't it amazing how nature can help us fight against infection?